How we learn to stop worrying and love AI and automation. Hello everyone, this is Stan Markov. I'm one of the co-founders and CEO of Runecast. And in this session, we'll talk about IT operations and what kind of worries admins have, what kind of sources of knowledge they're using, and we'll talk a little bit about how we can introduce automation, AI, in order to solve these worries. A little bit about myself. I'm VMware Certified Design Expert number 74, IBM Redbook author, vExpert, and also ex-IBMer. So I spent a lot of years in IBM together with my co-founders, and we did a lot of firefighting in IT operations, especially managing VMware environments. In fact, we built the VMware Center of Excellence within IBM, so we were managing most of the IBM customers running VMware across the EMEA region. We did a lot of firefighting, we had a lot of worries, and in 2014 we founded Runecast, and I will speak about Runecast Analyzer a little bit later, and I'll talk about how we solved all of these worries. But first of all, let me tell you about some experience that I've had personally in IT operations. First of all, what we worried about in day-to-day firefighting is service outages that were caused seemingly by seemingly undiagnosable problems. Of course, we were always spending time in trying to optimize our systems and to really help ourselves avoid any issues and outages out there, but we were always surprised by some seemingly undiagnosable outage and issue that we had to resolve. And sometimes it took really long days and nights, and sometimes even weeks of troubleshooting and root cause analysis until we got to the bottom of the problem. We had to continuously keep up with all the best practices of all the new versions of the products out there, also all the known issues that are documented, that our environments that we're supporting might have been affected by those problems. And last but not least, what was really stressful was also security audits. Of course, we spent long time to do manual health checks and manual security compliance checks on our environment. But anytime when there was a security audit, there were few servers or objects that were selected in the environment. And we had to almost in real time make sure that they are really configured according to the specific security compliance standard. And there were times when there were some findings, penalties, and really a lot of time and stress spent on that. I will tell you one specific story that I would say was one of the final drops that made us decide that there must be a better way of doing this, and we need to develop something in order to be more proactive. We had an outage on one of our customers, and one of their ESXi hosts on the vSphere cluster failed, along with all the virtual machines on it. Usually VMware High Availability is supposed to restart all these virtual machines on the surviving hosts, but for some reason it didn't work this time. So there was a huge panic for that customer, a lot of service outage, a lot of escalation calls, and actually took us days of troubleshooting to find out what the root cause of the problem is. It was pretty hidden because the error messages and symptoms that we're getting in the VMware environment did not lead to anything at first. Finally, we found a knowledge base article, the KB number is listed here, that was describing that if you have certain configuration of the heap size memory on the ESXi host and the virtual machines have access to a certain amount of gigabytes of disk space, then you might have problems with vSphere HA. So that was quite a hidden problem, and obviously because of the big service and business impact for that customer, the management team asked us to check all the customers, like really hundreds of customers in different environments, to make sure that they're not at risk from that single specific problem and misconfiguration. That really took actually a few weeks and a lot of effort to validate all of these customers and make sure that they don't have the same hidden problem. But this one KB article describing this issue is one of tens of thousands of knowledge base articles, many of which describe such bugs or known issues or best practices. And also these knowledge base articles are being updated all the time. The old ones are being updated. There are new issues that are being documented out there. It's really humanly impossible to keep track of that and proactively scan your environment or discover these risks. So we thought there must be a better way of doing this. In fact, when we look back at the problem tickets that we were solving and the root causes for them, we saw that over 90% of the root causes of serious outages and performance and security issues were based on known issues that were published somewhere in human-readable, unstructured format, in some knowledge bases, forums, or other sources of information. Just to give you an example, this is the VMware knowledge base and just one VMware knowledge base article, how it looks like. That's what you would normally read as a human when you are looking for more information on a potential problem. But if you just look closely, there's really some of these phrases and names here could be potentially used by a natural language processing module. And maybe this information could be properly extracted and then used automatically. Like, for example, ESXi host might crash is a very good phrase, or the category troubleshooting. VMware vSphere VMFS, it's a name entity as well that can be used, or disable unmap on the ESXi host as well. There's really various different sources of knowledge that IT operation teams are using in order to manage, optimize, and troubleshoot their environment. So the vendor knowledge bases are a very common one. But a lot of the issues and best practices are also published by influential bloggers, sometimes even before the actual vendor recognizes something as a potential problem or a known issue. It's very often published on blog articles or forums. Another source of knowledge is the hardware compatibility lists, white papers, vendor security guidelines, also popular security compliance standards like PCI DSS, CIS, NIST, HIPAA, and others, and of course the vendor documentation. So what if we find a way how to harness that unstructured human-readable knowledge and turn it into machine-readable rules so that it can be proactively used to discover those risks before they actually happen? That's exactly what we were thinking when we got to this point where we thought that we could just take a more proactive approach. So what you need for that is, first of all these sources of knowledge are different. Some are in HTML pages, some are in PDFs, text files, and so on. You need crawlers. You need to crawl all these pages continuously so that you can get all the new pages, for example, new knowledge base articles or old ones that are being updated. So you need to be able to have a number of different crawlers that bring all that information in one place. So that's the knowledge acquisition phase of the whole process of harnessing this knowledge. The second phase would be the knowledge processing. So all of this knowledge comes in different formats, in HTML, PDF, and sometimes in clear text. So that's why you need some parsers, standardizers, and also NLP preprocessors to clean up all of this data, put it in clear text, maybe remove all the data which is not necessary, which is not related to the particular problem or best practice, so that then the data is prepared for the actual knowledge extraction, which is the next phase. In the next phase, we'll be looking for specific name entities. So you need a name entity extractor based on name entities that are entered previously. So for example, in our cases like VMware vSphere or VMFS or ESXi version. Also noun phrase recognition. So with the previous case that I showed, phrases like disable unmap, fixed in this version, data store heart beating. So this can be achieved with the noun phrase recognition. In this phase also what you would need is a knowledge dictionary translator. So pretty much translating these noun phrases and name entities into specific configuration settings from the particular technology. So for example, if the knowledge base article talks something about you need to have changed block tracking disabled, probably the configuration setting on the VMware ESXi server side would be something like host.cbt.enabled equals true or false. And finally, in the knowledge extraction, also you need some scoring. So you need to score really what is the confidence level of the particular translation, and also how serious the issue could be. In the knowledge validation phase, now we would not be relying only on the automated AI or NLP modules to create the final rules from the original source knowledge. We are also here involving human experts, in this case, for example, VMware admins, that would validate really if this translation was proper, if this final creation of these automated checks and automated rules reflects what's written, for example, in the particular knowledge base article. And in the final phase, there should be continuous incremental learning. So making sure that this whole process is being improved continuously, and the level of confidence that's during this whole process, but particularly in the knowledge extraction phase, is higher and higher. Now, once we have this platform that together with NLP modules and also the human experts helps basically create these machine readable rules, we need a universal rules engine that can use those rules to analyze the particular environment, like in this case, a VMware environment, and discover potential risks based on those rules. So we need a rules engine that can work really at scale, and as inputs, the rules engine will receive all these rules that were created in the previous phases in a standardized language. And also a big input is a directed graph of objects and relations, which is pretty much the mathematical representation of any IT environment out there. Because if you think of your VMware environment, for example, as a directed graph, each one of the nodes of the graph would be either a ESXi host, a virtual machine, a vCenter, virtual switch or port group, data store, and so on. And all of these nodes, they are somehow interdependent. They have some relations between each other. For example, virtual machines would be related to the hosts because they will run on some of the hosts, or the virtual machines will be also hosted on some data store or connected to certain port groups or virtual switches. So all of these will be represent the relations between the objects. So we have as inputs all these rules, which could be thousands, and potentially a big graph with maybe sometimes millions of objects and relations. And as an output, what we're looking to find is, based on those rules, groups of objects that represent some potentially risky configuration. For example, if you have a knowledge base article that tells you that this host version and build number, and if it's managed by this particular vCenter version and build number, and also it works with a NSX controller that has a certain advanced setting, you might have a particular problem, for example, NSX not working properly. So in this case, we would want to isolate all the groups of hosts, vCenters, and NSX controllers that fit into this particular description from that knowledge base article. Of course, this is an example for just one rule out of potentially thousands. So considering the scale, we need to make sure that the rules engine that is handling all this can handle millions of objects and thousands of rules in a matter of seconds or minutes, and with minimum resources, which is a quite complex task to achieve. We at Runecast have already achieved that. We actually invented a new method how to handle that, just for If you'd like to read more about it, we received a patent for that. It's listed here on the slide. And last but not least, it's very important that we build this method to be universal. So I'm talking here a lot about VMware, but in fact, the rules and the rules engine, the whole methodology that I'm talking about here is universal. So it can be used for any IT out there. So let me now speak a little bit more specifically about Runecast Analyzer. So I was talking a lot about the end-to-end methodology we have for parsing all the knowledge, turning it into machine-readable rules, and then the need of having a universal scalable rules engine that could handle all these search in a matter of seconds or minutes. And we've achieved that with Runecast Analyzer currently for VMware and for AWS and for other technologies coming up in future. What Runecast Analyzer does is it uses information from the VMware knowledge base, VMware hardware compatibility lists, best practices from white papers and documentation, blogs and social media, also security hardening guides coming from VMware, and also various different security compliance standards like NIST, DISASTIC, PCI DSS, HIPAA, BSI, CIS, and we keep adding more and more security compliance standards to the list. So all of that information, which is being updated regularly, is used to analyze the configuration and logs of vSphere, vSAN, NSX, Horizon, and also AWS public cloud in order to continuously discover some potential risks and provide with steps on how to remediate risks for outages, for performance problems, or for security compliance gaps. Runecast Analyzer is pre-packaged into a virtual appliance. So it's one single virtual machine that's compressed into a 1 GB file that anybody can download from our website and import it into their infrastructure. There are no additional agents that you need to deploy. All the rules and the rules engine and the user interface, it's all already pre-installed and pre-configured into that single virtual machine. And you can, once you deploy it and set up the IP address, you can connect it to all of your vCenters, NSX managers, Horizon connection servers, and AWS accounts. And you can have an overview of all the risks on one single dashboard. Normally, you will deploy Runecast Analyzer on-prem, and in fact, you don't really need to configure internet connection either, so it works even for dark sites. Everything will work out of the box without connecting Runecast Analyzer to the internet. It is still recommended to update it on a weekly basis because all these sources of knowledge that I mentioned earlier are changing and evolving all the time. And our internal AI-assisted knowledge parser, this platform for parsing knowledge, it's working all the time, and we're releasing updates on a weekly basis with the latest information from the hardware compatibility list, on knowledge bases, and so on. All of that goes into the Runecast Central repository, so the individual instances of Runecast Analyzer can update themselves, either in an online way without any human intervention, or if you're running Runecast Analyzer in a secure dark site, then the admin can just download an offline update package and attach it to the Runecast Analyzer virtual machine and perform the update this way. You can deploy Runecast Analyzer in minutes. Literally, it's just importing an OVA, setting up the IP address and connecting it to your vCenters. And it will help you with discovering all the potential risks in your environment. It also keeps all the configuration and log analysis history. So you can go back in time and see what changed, what caused an issue to be reported or issue to be solved. It not only gives you the current situation and historical data of configuration log issues, but also it enables you to simulate upgrades of your environment, which you have to do from time to time. And that's one of the things also we're worried about, because very often if you do an upgrade, it's really hard to pre-calculate everything and make sure that there'll be no issues or outages once you go with the update. So we included a functionality called Upgrade Simulator, which can enable you to choose a different version of vSphere and see whether you'll be fully compatible in terms of IO devices, drivers, firmware, and so on. Runecast Analyzer is also highly scalable, so you can have multiple vCenters, thousands of ESXi hosts, and many AWS accounts, and all you need is one single Runecast Analyzer appliance to handle all of that. But we also provide an enterprise console dashboard if you want to scale out Runecast Analyzer to multiple geographical locations. Each one of the Runecast Analyzer can have the enterprise console dashboard enabled that will collect information from all the Runecast Analyzer instances into one single place. Our customers report saving a lot of time from troubleshooting, health checking, upgrade planning, and saving, of course, a lot of costs from all of that, but also from potentially hiring external resources to do all of that for you. With Runecast Analyzer, you can reduce outages in ways that you cannot do in any other way. So you can discover and remediate hidden issues before they cause some service outage. So it really helps you to reach your SLAs. Another important thing that is really valuable to our customers is the automation of the security compliance of their VMware and AWS environments. You can be 100% audit ready, and you are you can use the automated security compliance auditing and reporting. So anytime you have an audit, you have out-of-the-box reports for your current security compliance posture, but also your historical security compliance posture as well. There are a few slides here that I included with some screenshots from the product, but what I would really encourage you is to just go online to runecast.com. We have an online demo, so you can play with the product, or you could just register for a free trial and download the 1 gig OVA and try it for yourself. And maybe you'll see that you or your team will stop worrying and you will love AI and automation, and in this particular case, also Runecast Analyzer. This has been great. My name is Stan Markov. You can follow me on Twitter, and thank you for joining today's session.